Hi, I'm Dave Shook. We're going to be talking about data acquisition from operational technology systems uh, as the first in a series of videos about some of the challenges that you encounter dealing with operational data and getting value from it in the cloud. So first of all, we're going to start with a relatively basic diagram of what an industrial networking system looks like. Here we have some industrial equipment, a pump and a motor, flow meter and a flow transmitter, controller that's controlling the flow rate as part of a distributed control system or industrial control system, firewall, then a demilitarized zone or DMZ network, followed by another firewall going through the corporate business network, another firewall out to the internet, and then into Microsoft Azure or whatever your cloud happens to be. We're going to be talking about the security aspects in a subsequent video, but for today, I just really want to talk about the complexities involved in acquiring this operational technology data in the first place. So first of all, the process data, the flow rate, and the actions taken by the controller are collectible from the control system itself. The technology for doing this is pretty mature. It's largely based on a set of protocols called OPC. Not entirely, but most control systems support OPC, or you can get OPC connectors. Usually then what happens is there's something called a historian running in the DMZ that collects these values at some interval and stores them locally. Now, in addition to those signals and calculations carried out in the control system can also detect alarms or other sorts of events. This data is structurally different from the data in a historian, and so it tends to live in an alarm and event database, often abbreviated as A&E. This data is quite different from the historian data in terms of the data structures and how it's queried. So it tends to live in a different system. Now, unfortunately, there's additional data down here pertaining to the operations that doesn't even make it into the historian or the alarm and events server. So for example, the motor control and things like vibration measurement often don't make it into the control system directly. Instead, what happens is there's an auxiliary set of computers, either specifically for vibration monitoring and almost certainly for motor control. And these systems are sophisticated in their own right, and they have got quite complex computation within them, but the data that they produce is often not that digestible by the control system. So you might get a small, thin subset of the data transmitted to the control system so the operator can detect if something has gone badly wrong, or so the operator can start or stop the motor controllers. But a lot of the data in vibration systems and motor control systems, and even things like instrument diagnostics, tends to be stranded in the control system, or even stranded upstream of the control system. So if you want to do any meaningful analysis on these equipment, especially within the context of the overall process, you often need to put some sort of auxiliary data acquisition system in place to collect the data from the vibration systems or from the motor control systems and get that data out to the cloud. In these days of intelligent IoT devices, intelligent monitoring devices, sometimes these systems can communicate all on their own up to the cloud because they're just doing monitoring and they're not capable of affecting the process. They don't have to move through this series of firewalls necessarily, but you still have to acquire that data. So in order to be able to do meaningful analytics in the cloud based upon your operating data, you actually need to acquire the operating data to begin with. And so what we do and what we encourage people to do is to put some sort of data acquisition client here within your DMZ or possibly even on these auxiliary networks that can then transport that data up to Azure, and which can deal with the fact that, historian data or OPC data is structurally different from alarms and events, that vibration data is structurally different from simple flow measurements, and so on. Hope you enjoyed this video. If you have any questions, please feel free to follow up with questions. We'd be happy to answer them.